Ivy Terrace Park. This is video 3-6, Special Characteristics. So far we've looked at characteristics that we can describe on each of our three functions so far, linear, quadratic, and exponential. In this lesson we're going to take a look at features that are just specific to one or two of the functions and not everything else. We're going to look at some specific features of exponentials and some specific features of quadratics. Alright, let's go ahead and get started.
Welcome to lesson 3-6. In video 1 we are going to take a look at some characteristics that are unique to our quadratic functions. Specifically we are going to take a look at the vertex and the axis of symmetry. So we'll start out by taking a look at the vertex. Now the vertex is the minimum or maximum point of a quadratic function. Since this is an actual point, we should always be writing our vertexes as an ordered pair, an x value and a y value. Now when we have a parabola that opens upward and that contains a vertex, it's going to be a minimum point. So our parabola on the left here that opens up, that little red dot on it would be our vertex, and that is going to be a minimum point because it is the lowest point on that graph. On the other hand, if we have a parabola that opens downward, the vertex is going to be a maximum point. And we can see that on our quadratic on the right here. Our red dot will still be our vertex, but this time it is at the top of the function. So a maximum of a quadratic is going to be the highest point on the graph of an upside down U-shaped function. So just like we had on the earlier slide, we have the same thing, but this time you can see it in the context of an XY axis. And then the minimum of a quadratic is going to be the lowest point on the graph of a U-shaped function. Alright, just to avoid some confusion, the notes got a little bit misaligned. We are talking about the minimum right here that's going to match up with this example over here where we have a minimum. But if we're looking at the vertex and we're looking at the range, then the range is going to be all real numbers greater than or equal to the y value. So our range will start with this little red dot here and will include all the y values that go up from there. So it would be y greater than or equal to whatever that y value is. Now if we look at a maximum situation over here, and just remember that's going to match up over here with a maximum right here. If we're looking at the range, the vertex is going to be a maximum, then the range is all real numbers less than or equal to the y value. You see the maximum point is here at the top. We want all the y values that are going to be below there. Now we do sometimes refer to the maximum and minimum as the extrema, so anytime you're asked for the extrema, it's a general term that could mean the maximum or the minimum, and you'll just have to determine which based on the situation that you're given. We also have something called an axis of symmetry. It may also be referred to sometimes as a line of symmetry. And what the axis of symmetry is going to do is divide the parabola into mirror images. The line of symmetry is always a vertical line of the form x is equal to n, where n is a real number. The axis of symmetry can often be abbreviated as AOS. So anytime that you see on mastery check or practice that you're being asked for the AOS, that is referring to the axis of symmetry. And we have our illustration over here to the right. We can see a quadratic, one that opens up, one that opens down. They both have the axis of symmetry that goes right through the middle, and it's going to cut right through the vertex. So you're actually going to see that when you give the vertexes ordered pairs, the x value will also be what you're going to plug into your equation for the axis of symmetry. It will be x equals whatever that x value is. And that's true for both ones that open up and that open down. So let's go ahead and look at some examples. We want to identify the vertex of each function. We want to tell whether the vertex is a minimum or maximum. And we want to write an equation for the axis of symmetry. So we'll start out with example A, the green parabola. We want to first find the vertex. So this one opens up, and we're going to find the vertex right here at the center. And we can see that that point is going to be 0, 0. So that is our vertex. And as we said, it opens up, so this is going to be the lowest point. So this is going to be a minimum. Now our axis of symmetry is going to cut straight through there. If I were going to draw it, it would come in just like this through the middle. Remember, the x value should match our vertex, and it always has to be an equation, and it's going to be a vertical line, so it's going to be x equals, and that x value that it goes through is 0. So we have our vertex, It's a minimum, and our axis of symmetry is 0. X equals 0. Now let's take a look at example B in the red. We're going to look for the point that is at the very top here. It looks like our ordered pair is going to be 4, -4, so that will be our vertex. Remember, we always want to give the full ordered pair. This one is going to open down, so that means that this is going to be a maximum. And our axis of symmetry is going to be what cuts straight through the middle, straight through that vertex. And we know it has to be x equals. We go back up to our vertex, we can also see it on the graph. That is going to be x equals 4. Alright, you guys give the you try problems a try. Check your answers on the website and come back for video 2. See you guys then.